This is ICSE 2024 chemistry paper, that is science paper 2, which was held today. We have already finished with section A, that was MCQ, and question 2, that is a total of 40 marks. We finished solving this and I've already uploaded these videos, so somewhere on the right corner you will be able to see the links of those videos. Section A being done, we are moving on to section B. Section B consists of again 40 marks, but in this section any 4 questions from 6 questions we have to solve. So first question of section B is question 3 and the last one will be question number 8. Each one of them is going to be for 10 marks and I'm going to solve each and every one of them. You check where you're getting marks, where you're losing marks, how the perfect answer should be written. Because of the 42 plus years of experience, I tend to give you a guidance regarding how the paper should be written. For example, this is a 2-mark question. There are 2 marks. So each will be given 1 mark. And then again, how you should be presenting your work, how you have to think for the given question. All this is going to be explained in this video. So watch the video till the end. And at the end of it, write the marks that you would possibly get. And then we can check it up when the board results are out, whether they were the same marks as you have counted now. Let us begin with our question 3. So question 3 has number 1, rewrite the following statements by adding the correct word shown in the example. And the example is given. If the given statement says ammonia changes moist red litmus blue, then the correct statement is aqueous ammonia changes moist red litmus blue. So we have to add the correct word. Let us look at the first one. Sulfuric acid acts as a dehydrating agent. Now dehydrating agent is possible only when sulfuric acid is concentrated, not dilute. So here we will rewrite this saying concentrated and then underline this concentrated as they have underlined here. Concentrated sulfuric acid, you will have to write up to here, acts as a dehydrating agent. Let us look at B. Ammonia reacts with chlorine to give ammonium chloride and nitrogen. Now ammonia with chlorine, there are 2 reactions. One is with excess ammonia and excess ammonia gives these 2 products. So we will write over here excess. So the correct word which is missing is excess ammonia reacts with chlorine to give ammonium chloride and nitrogen. If it is excess chlorine, then it will give us nitrogen trichloride and hydrogen chloride. Let us continue with question 3, second part. Identify only the anion present in the following compound. A says the compound on heating produces a colorless, odorless gas which turns lime water milky, which means it could be either sulfur dioxide or carbon dioxide and has no effect. Now when it says no effect on acidified potassium dichromate solution, which means it is not SO2, it will be CO2. Carbon dioxide has been released. Now which anion is going to release carbon dioxide? It has to be carbonate. So we will write the anion. So we'll write A and we will write carbonate. And into bracket we will write the formula CO3 2 minus. Subpart B, a solution of compound which on treating with concentrated sulfuric acid and freshly prepared ferrous sulfate produces a brown ring. That brown ring test is a typical test for nitrate radical when we take freshly prepared ferrous sulfate. So for our B, we will write nitrate. The symbol of that is NO3 1 minus anion. So we finished with the 2 marks. Now let us come to the third part. Mohan has 3 solutions P, Q, R, and their pHs are given as 13, 5 and 2. Now remember, more is the pH, more alkaline it will be, and less is the pH, more acidic it will be. So which of the above solutions PQR will react with magnesium to liberate hydrogen gas? Now magnesium is active metal. It will liberate hydrogen gas from the acid, and that too from a dilute acid, a strong acid. So it will have to be pH 2. Now 2 pH is for R. So we'll write R here. Why? Its pH is 2, so it is acidic. Which one of these will liberate ammonia gas when reacted with ammonium chloride? Now ammonium chloride, the ammonium part of it will react with hydroxyl ion of the alkali. So we'll need to add alkali. Which one is the alkali which should react with this? So the alkali here will be with pH 13, and that will be P. So this will be P. Which contains molecules as well as ions, which means it is going to be a weak acid or a very weak base. Now you can see over here 5. 5 means it's a weak acid. Weak acid will have molecules as well as ions, and 5 means it is Q. So that gives us our 3 marks here. And we finish with the 7 marks of question 3. We come to the fourth part, which is for 3 marks. We cannot see this, but here it is. The following table is related to the industrial process of an acid. Name of the process, but the reactants are sulfur dioxide and oxygen, which means your A is contact process. Contact process is for industrial manufacture of sulfuric acid. The reactants are here. What will be the catalyst here? B means catalyst. Catalyst is vanadium pentoxide. What is C? The final product. What is the final product? It is sulfuric acid. Now remember, we prepare sulfuric acid from oleum. Now in oleum we have to add requisite amount of soft water, and we get the final product as sulfuric acid. And I would like you to write of the desired concentration. Because the concentration depends upon how much of soft water was added to it. Now some of you may have attempted question 4, which in the first subpart, which is for 3 marks here, is the definition. Now molar volume, volume of 1 mole of a gas at STP, and normal salt, where the salt is obtained by complete replacement of the replaceable hydrogen atom of the acid. So you can learn up these definitions. You have to check with your textbook, and accordingly you will be giving yourself marks. Draw the electron dot structure of methane molecule and nitrogen molecule. For methane, we will show carbon with 1, 2, 3, 4 valence electrons plus hydrogen with a cross. This hydrogen with a cross, that is the valence electron and the only molecule of hydrogen, and we have the shared pairs shown like so. That will give us C, single bond H, single bond H, single bond H, single bond H, and that will give us CH4, which is the methane molecule. For B part, nitrogen molecule, remember your nitrogen is atomic number 5, which means there will be 3 more electrons required to complete its octet. So we write nitrogen with these 3 electrons and these 2, that makes it 5 electrons. The valence electrons of nitrogen, and this nitrogen with these 2 and these 3. And these 3 electron pairs are shared, will give rise to nitrogen triple bond nitrogen, and that will be nitrogen molecule. Okay, so this was again 1 mark each, 1 mark each. So if you written this way, give yourself those marks. We come to question 4, part 3. Complete and balance the following equations. The first one is aluminum oxide with NaOH. Now aluminum oxide is an amphoteric oxide. It will react with an alkali to give salt and water. And what type of salt it will give? It will give NaAlO2 plus H2O. For this, we have this reaction taking place here. This is the preparation of alkanes. So we will get Na2CO3 and C2H6. Let us see how we write these reactions. See the first one, NaAlO2 will be formed. So Al is 2 here. So in order to balance that Al, we'll write 2 here. So Na becomes 2. So you will write 2 here. Got that? Now check H2O. 2 H's, it has 2 H's. This has 5 O's. This has 4 and 1, 5 O's. Look at this. This is Na2CO3 that is here, and C2H5, and this H will make it C2H6. This is ethane gas. Now this may be a little demanding for you. C2H4Br2. So it is not C2H5Br, which means there is C single bond C, and there will be Br here and Br here. Now per carbon, if there are 2 hydrogens, it will give you C2H4 and Br2. So we will need plus 2 KOH, alcoholic KOH, like so. So 1 K will take this Br, make it KBr, and another K will take this Br, make it second KBr. And this OH will go with H, give you water molecule here and water molecule here. So that will give us 2 KBr, 2 H2O, and here these electrons of these will come here forming a triple bond. So it will be C2H2 plus 2 KBr plus 2 H2O, and we have taken 2 KOH. This is a dehydrohalogenation reaction. It is a little tricky, but if you have studied it well, you should be able to get those marks. This was 1 mark each, so 3 marks here for you. Choose the organic compounds from the list below to answer the following questions, says the 4th subpart. And we have ethene, that is C double bond C. This is ethanoic acid, so C single bond C, double bond O single bond OH, and they will be this here. Let me just put the structure here. Now ethanol is C single bond OH, and this will be CH3 CH2. Methanol will be C double bond O single bond H and 1 H here. They are saying the compound which does not have a double bond, which does not have this one, does not have double bond. So that is your ethanol. B. The compound in its pure form turns into an ice-like solid on cooling is acetic acid, which is also called ethanoic acid, that is the IUPAC name of acetic acid. The compound which is used for artificial ripening of fruits, this will be ethene. You can even have ethyne for ripening the fruits, but in our options we had ethene. So that is how we get full 10 mark for question 4. 4. Give yourself marks, write in the comments. Question number 5. If you have attempted this question, then check for the answers. They are very simple. The main metal in making the alloy is given below. Duralumin has aluminium as the main metal and stainless steel has iron as the main metal. Second one, differentiate between the following pairs based on the criteria given. A. Sulfuric acid and nitric acid using barium chloride and unsaturated and saturated hydrocarbon from the type of bonds present. Let us see how we present our work in this. We make two columns like this for sulfuric acid and nitric acid, and here we write the test. That is, add BaCl2, that is barium chloride solution, to each. Now barium with sulfuric acid will combine with that SO4 radical and it will form BaSO4, which is a white precipitate, and that is insoluble in dilute HCl. That is the test for sulfate radical. So if we get white precipitate, we say that SO4 2 minus is present, therefore dilute H2SO4 is present. But with nitric acid, barium chloride will become barium nitrate because of this NO3 radical, okay, nitrate radical. So barium nitrate is soluble, so there is no precipitate, so we write if no precipitate, then nitric acid is present. So for B part, again we'll make the three columns. First one we'll talk about the type of bond, and we write for the second column here unsaturated hydrocarbon and here saturated hydrocarbon. In unsaturated, remember there will be presence of double or triple covalent bond between at least two carbon atoms. Remaining can be single bonds. Saturated hydrocarbon will have single covalent bonds between all carbon atoms. So here the keyword is double, triple covalent bond, and here single covalent bond. Your next subpart is 3. Calcium carbonate reacts with dilute hydrochloric acid as given below, and we have been given this reaction. A part says what is the mass of 5 moles of calcium carbonate? Relative molecular mass of calcium carbonate is 100. How many moles of HCl will react with 5 moles of calcium carbonate? And what is the volume of carbon dioxide liberated at STP at the same time? Now this is a 3-mark question. So 1 mark for A, B and C each. In order to solve this, we'll have to write this first, and then we'll write the data that is given. 5 moles of calcium carbonate has been given, and what all are the quantities to be found out, that also we'll write in the chemical equation. We write the chemical equation like this. What is given? 5 moles of CaCO3. What was our A part? Find the mass of CaCO3. What was a B part? Find the number of moles of HCl. What was part C? Find the volume of CO2 at STP. So we write for mass, the RMM has been given, so we write here GMM, which will be 100 grams, okay, and this is 1 mole of it. So we are going to make 2 columns. We will write number of moles and we will write number of we write the mass. Now if it is 1 mole of CaCO3, its mass is going to be 100 gram. But if it is 5 moles, then how much? So this will give us 100 into 5, which is equal to how much? 500 gram. Mass of 5 moles of CaCO3 is equal to 500 gram. And that is our answer A. For part B, They are saying find the number of moles of HCl when 5 moles of CaCO3 are reacting. Now here there is one molecule, so there is 1 mole here, and there are 2 molecules here, so that is 2 moles it will correspond to. So we are going to make 2 columns, moles of CaCO3 and moles of HCl. From the equation, if there is 1 mole here, then there are 2 moles here. So if there are 5 moles, then as you can see, this is very simple. So you will say number of moles of HCl reacting with 5 moles of CaCO3, that will be 10 moles. That is our answer B. For C part, 5 moles of CaCO3 will give us how much of volume? Now there is 1 mole over here, CO2 is 1 molecule, so it will be 22.4 liters at STP. So if there is 1 mole here, then there is 1 mole here. We are going to make the first column as moles of CaCO3, and here it will be volume of CO2 at STP. If there is 1 mole of CaCO3, then corresponding volume here is 22.4 liters. So if it is 5 moles, then it will be 5 multiplied by this. And the answer will be at STP. And we will write the answer as volume of carbon dioxide at STP at the same time, volume of CO2 at the same time would be equal to 112 liters, and that is our answer C. 1 mark for this, 1 mark for this, and 1 mark for this. So hope you are getting full marks so far. Write in the comments whether you got for this question 3 full marks. We come to the 4th subpart. This is again a 3-mark question. Identify the gas evolved in each of the following reactions. A says methane undergoes complete combustion. Now methane is CH4. If you combine it with oxygen, that is your combustion reaction, we will have gas evolved will be carbon taking oxygen will be carbon dioxide. Of course, you will get water vapor also as a gaseous product, but that will not be considered under this. So we have to write carbon dioxide. If you write the formula, you will lose all your marks. So just take the pen enough to write this. Then copper carbonate is heated. Copper carbonate is CuCO3. It is going to decompose into copper oxide and CO2. So again we will have to write carbon dioxide. MnO2 is heated with concentrated HCl. Here we have MnO2 being oxidizing agent is going to oxidize HCl. So we will have chlorine gas, which is greenish yellow gas. That finishes our question 5. Now we come to ICSE 2024 chemistry paper, section B, question 6. So from section B, we finish question 3, 4, 5. So this is the 4th question. Now remember, out of 6 questions, we have to solve 4 questions. So if you have written 3, 4, 5, 6, these questions in section B, then immediately after this you will come to know what is your score. If you have watched the earlier videos, you will know how much you have scored in section A, and then you will know your marks. So at the end of this video, write the marks if you know out of 80 how much you are getting. Your first part, X is a reaction. HCl dissociates into H1 plus and Cl1 minus in solution state, that means in aqueous state. and why is PbBr2 dissociates into Pb2 plus and 2Br1 minus in molten state. From the above reactions, X and Y, identify the reaction that exhibits electrolytic dissociation. Now, electrolytic dissociation will be in an ionic compound where ions are already present. So, your A is going to be Y, which is PbBr2. That's all you have to write. And for B, ionization is for covalent compounds. So already molecules are here. They have got converted into ions in solution state. So ionization is X. That's all you need to write, and you get your 1 mark and 1 mark, and your 2 marks are with you. Second part says give reasons for the following. A. Inert gases do not form ions, and B. Covalent compounds have low melting and boiling points. For this, I have written the answers the way they should be written. So let's look at them. So I have written down the question. Now the answer is never start it with the word because. Say this is so as. The inert gases have, what is the keyword? Complete octet or duplet. That means they have stable electronic configuration. Hence, they will not need to either gain or lose electrons and cannot form the ions, which means either cation or anion. They will not be formed. Now, here there is one more phrase. They do not need to gain, lose, or share electrons. But remember, sharing electrons doesn't form cation and anion. So that part I have not written. Just gaining electron means anion and losing electrons means cation. So they do not gain or lose, so they do not form ions. We come to B part, where covalent compounds have low melting and boiling points. So covalent compounds have a very weak van der Waals force between the molecules. This force is overcome with less energy. So with less energy supplied, it is going to have change of state. So that will result in low melting and boiling points. The third subpart tells us to arrange the following as per the instructions given in the brackets: carbon, fluorine, beryllium, and decreasing order of atomic size. Now these questions I have written on the paper and the answers look like this. So carbon, fluorine, and beryllium, decreasing order of atomic size. Now remember, you have to first write them in the order it is in the periodic table. So in your mind or in your rough column, you will first write beryllium, then you'll write carbon, then you'll write fluorine. Now remember, atomic size decreases across the period. So decreasing atomic size means I'll start with beryllium, then carbon and fluorine. I write like so. So that is your 1 mark. The second one, these acids have been given. An increasing order of the number of replaceable hydrogen atoms per molecule has to be written. So we start with the replaceable hydrogen. In H2SO4, it is 2 hydrogen atoms per molecule. In case of this phosphoric acid, there are 3 hydrogens, and acetic acid, it is this one that is replaceable. Don't say this is H3 and this H4 hydrogens, because this is the methyl group. This is not the one which will be replaced when the reaction take place. Okay, so we start with this is 1 replaceable hydrogen, 2 replaceable hydrogens, and 3 replaceable. So the order is first acetic acid, then sulfuric acid, this one, and then phosphoric acid, and that's how you'll get your second mark here. The third one, the C part, K, Li, and sodium, we've been given the names, but I'm writing it in short, increasing order of ionization potential. I've just written IP. Now remember, you have lithium, sodium, and potassium. They are group 1A, and as we go down the group, the number of shells are going to increase. So IP is going to be less here and more here. So lithium is going to require more ionization potential energy. So here there will be max IP and here it will be min IP, minimum IP. So increasing order means we will write this way. So how do we write? Potassium, sodium and lithium. That is your correct order and 3 full marks here. Fourth subpart, which is the last subpart of question 6. Identify the following. A. An element in period 1 which can be placed in both group 1 and 17 of the periodic table. Period 1 has hydrogen and helium. So, helium being the noble gas, only hydrogen can be in group 1 where it behaves like a metal and in 17 where it behaves like a halogen. So, which is the element? For B, the element having electronic configuration 286. It has 3 shells, so it is period 3 and it is going to be group 16. So it will be, if you look at your thinking process, you will have sodium, then magnesium, then can you see this? This is the 6th one. So this will be in group 16. So the element will be sulfur. The most electronegative element of period 3. Period 3 will end your sulfur and then chlorine. Chlorine will be the halogen. So for C, we will write chlorine, which will be the most electronegative element of period 3. So now we have to start with question 7. But remember, from section B, we have finished 3, 4, 5, 6. 4 questions we have finished solving. So if you have attempted question 3, 4, 5, 6, then write in the comment box out of 80 how much are you getting, out of 40 in section B how much you are getting. Let's come to question number 7, first part. Rita was given an unknown salt for identification. She prepared the solution of the salt and divided into 2 parts. In the first part, she added few drops of ammonium hydroxide and she obtained reddish brown precipitate. That means Fe3 plus was present. You have to know the colors of the precipitates in ammonium hydroxide and even sodium hydroxide. So this was the cation that she got, and to the second part she added few drops of silver nitrate and she got a white precipitate. Now silver from here reacted with the anion of the solution and white precipitate would be AgCl. That means she must be having chloride radical in the unknown salt. The cation present you have to name. So your A will be ferric ion, that is the cation, and write into bracket Fe3 plus. And anion present was which one? Chloride. So we write chloride ion and that will give us Cl1 minus. Question 7, second part. Fill in the blanks by choosing the correct answer from the bracket. A. Carbon tetrachloride is a non-polar covalent molecule. The reason is because carbon will be sharing electrons with chlorine, and these electron pairs which are shared, they are equally distributed, so there is no charge separation. So the correct answer is here non-polar, yes. And B, during electrolysis of acidulated water, the gas liberated at the anode is. Now if you are not directly getting the answer, you should show the steps where we show H2O dissociating into H1 plus and OH1 minus. Now this will migrate to cathode. So at cathode H1 plus will gain 1 electron, correct, to give hydrogen. But at anode we will have OH1 minus which will lose 1 electron and it will give us neutral OH, which is unstable, and you know that it has to be multiplied by 4. So we'll have 4 OH giving us 2 H2O plus O2. The moment you see this, our answer will be oxygen, and you will get your 2 full marks, one for this, one for this. And let's move on to the third subpart. The third subpart, ammonia burns in oxygen as shown below. So we have 4NH3 plus 3O2 gives 2N2 plus 6H2O, and 240 cc's of ammonia burn in 300 cc of oxygen. So ammonia, the volume of it, and oxygen also the volume has been supplied. Find out the composition of the resultant gaseous mixture at room temperature. At room temperature, remember, this is steam which will be condensed and it will form water. So we have 4 volumes of a gas combining with 3 volumes of another gas, forming yet another gas, and we have steam. So here we'll apply Gay-Lussac's law, but for 6H2O at STP it will be water, so we will not get any steam at room temperature. Let us see how we are going to present our answer for this. We write down the reaction, and 240 grams, 240 cc's of NH3 has been supplied, combining with oxygen, which is 300 cc. And we now apply Gay-Lussac's law, saying this is 4 molecules, so that will be representing 4 volumes of ammonia, yes, and oxygen will be 3 volumes here, and that will give us 2 volumes here of nitrogen and 6 volumes here, and I'm going to write over here according to Gay-Lussac's law. But you will see that 240 cc's are going to be 4 volumes, so each volume is going to be 4 into 60. Each volume is going to be 60, so 4 volumes will be 4 into 60 cc's. Now you will say that this volume also has been given. What if we consider this? Then 3 oxygen molecules, and that will be corresponding to 300 cc. So one volume will be 100, which means for ammonia I need 400 of ammonia. Do I have 400? No. So I have to consider 240 cc's as 4 volumes. So each volume is 60 cc. So we write here 4 into 60 cc, here 3 into 60 cc, here 2 into 60 cc, and here we will write not applicable since it is water at room temperature. So Gay-Lussac's law is pertaining only to the gases. So we do not take any liquid in that. So volume of oxygen used over here is 3 into 60, which is 180 cc. So how much is the unused oxygen? They supplied us 300 cc. So 300 minus 180 means 120 cc was the unused oxygen, which will be there in the resultant mixture here. And also we will have volume of nitrogen formed, that is 2 into 60, which is 120 cc. So we write the resultant mixture has, can you see that, 120 cc of oxygen, which is unused, and 120 cc of nitrogen, and we say that is our answer. The fourth subpart of question 7 gives us a table and the electronic configurations of A, B, C and D elements. So A has 2882 as the electronic configuration, B has 2, 6, C has 287 and D has 2, 4. Write the formula of the compound formed between, that is your A part. Now A is going to have 2 electrons in the valence shell. So A is going to be forming a cation with 2 plus. And B is 2, 6. So it's going to gain 2 electrons and it will become an anion, that is 2 minus. The metal is A, non-metal is B. So with crisscross we will get A2B2, but we will not write A2B2, we will write AB because we have to cancel the common factor there. Now D and C. What is T? 2, 4. So this is a non-metal. And C is 287. This is also non-metal. So the bond between them is going to be covalent. And D with 2, 4, it needs 4 electrons. So your D will have C, 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 C. Each one of them will be taking one electron, rather sharing one electron with D, and therefore we will get DC4. This is the compound formed between D and C. Now compare this. You know 2, 4 is what? It is carbon. 287 is what? It is chlorine. So don't we get CCl4 as the compound between the two? So it is correct, DC4. Which of the above elements will exhibit catenation? Now catenation is organic chemistry definition. You know the meaning of that. You know it is for carbon. Which is carbon over here? So write over here D. And that gives you your 1 to 3 marks. So I hope you are getting 10 on 10 in this question also if you have attempted it. We now come to the last question of this paper. So if you have attempted question 8, check your answers. Number 1 says choose the correct answer from the list given below. So we have zinc blend, C2H2, calamine, CH, hematite. The ore which can be concentrated by magnetic separation. Magnetic separation is when either the ore or the gangue will be magnetic. So which one is magnetic in nature here? Hematite. So you will write for A, hematite. That is the iron ore, right? Now, empirical formula of ethine. Now thinking step is ethine is C2H2. So empirical formula is going to be CH. So we'll write for B, CH. This is the empirical formula. This is your A, hematite. So as simple as that to get your full marks. 1 mark for this, 1 mark for this. Let us come to the second one. Give balanced equation for the following reactions. Copper reacts with conc nitric acid. Now copper reacting with conc nitric acid, Cu plus 4HNO3, and we will write concentrated, and that on heating copper will take nitrate, so it will become CuNO3 twice, plus it will give H with that O, H2O. That will be 2H2O because there are 4 H's here. Can you see that? And plus it will give 4NO2 up arrow. So remember H2O and NO2, they are like a package deal with concentrated HNO3. So copper will take nitrate, become copper nitrate, and H2O NO2. Remember to write 4 here. So 4 H's will give you 2 H2O because H will be 4. And how many N's do you see? 4. So 4 NO2. Next we come to aluminium nitride reaction with warm water. So we'll have ALN. Al is 3 plus, N is 3 minus. So ALN. Plus you have to know these reactions. This is warm water. Don't forget to write here warm. And Al will take OH from here. Look at it as H and OH. So Al will take this OH and it will become ALOH thrice, which means I'll need 3 OHs. I've written 3 here. Now what is remaining here? N and 3H means, okay, so 1 mark for this, 1 mark for this. Easy to get full marks, right? We come to the third subpart of question 8, which is match the following column A with column B with the suitable method of preparation. This can be a little overwhelming for some of you, but let us look at it. Let's think very carefully. ZnCl2 from Zn. So if you are given Zn, I'll have to add something to get ZnCl2, correct? So zinc, this will give me this. And for this, I'll have to take HCl dilute, correct? So zinc will displace hydrogen and it will give me simple displacement reaction. So this will be 3. And then you write displacement reaction. Look at our B, KNO3 from KOH. So we have to take KOH and then from that we have to get KNO3. Now KNO3 has K which will come from here. And what is this? This is a base. And what is this? This is neither H nor OH, means it's a salt. So I will need base is giving me salt. So I'll have to take an acid here and I should take acid which has NO3, which means I will have HNO3. Can you see what has happened? Can you see base and acid will give me salt and water? So it's a neutralization reaction. Where is neutralization? 4. So write for B 4 and write neutralization. C is CaCO3 from CaCl2. Now CaCl2 we have to take and from that we have to prepare CaCO3. Now this CaCl2 will give me this calcium here, but I need to take something here with CO3. Now you know that calcium carbonate is insoluble, so it will come as a precipitate. So I should take a soluble salt here and a soluble salt here. CaCl2 is already soluble, so we'll have to take Na2CO3. That will give me CaCO3 plus 2NaCl. I'm not writing that 2NaCl, I don't have space. But what has happened? It is precipitation by double decomposition of 2 soluble salts. So which is precipitation here? 1. And we write precipitation. So 1 mark for this, 1 mark for this, and 1 mark for this. This was a little tricky for some of you, but those who know this topic well, it was a piece of cake. We now come to the last part of the last question. And this is also for 3 marks. You can see 1 mark each. Hydrogen chloride gas is prepared in the laboratory by the action of concentrated sulfuric acid on sodium chloride. Give balanced chemical equation for the above reaction. Let's see how we write it. State the method of collection of the gas formed above and see what is the property of sulfuric acid that makes it suitable reagent for this reaction. Let us see how we write it down. So everybody by now must be knowing this reaction. We take concentrated H2SO4 with this and we will have this type of double decomposition, which is half double decomposition happening, and it gives us NaHSO4, which is the acid salt, and H with Cl gives HCl. So this is your A part. Suitable method of collection is upward displacement of air because hydrogen chloride is heavier than air. Vapor density 18.25, but vapor density of air is 14.4. Then see what is the property of sulfuric acid that makes it suitable reagent for the reaction. And here we write sulfuric acid is a non-volatile acid, hence displaces the volatile acid like hydrogen chloride from its salts. Hence displaces volatile acid like hydrochloric acid from its salt. And that finishes our last 3 marks, and hopefully all of you are getting 80 on 80. Okay, so do write in the comment box how much you are anticipating, and also I want to wish you all the best for your results for your next few papers that are remaining, and I want to thank you for watching. Bye.